Good day. So today we are going to have an example on how to apply the 8 steps in hypothesis testing. So we have here basically 8 steps. Some notes will say 7 steps, but that's because of for the step 7 and step 8, sometimes conclusion and interpretation can be incorporated in the last step, that's in step 7. So we have here the first one is we really identify first what is the parameter of interest. So that is depending on the problem that is given. And the second one is having or formulating the null hypothesis. And the third one is formulating the alternative hypothesis, after which we will determine what type of test statistics we are going to use, whether we are going to use a z-test or a t-test or an f-test or an f-distribution test. And then the next one, step 5, is establishing the rejection region. So that will also depend on what level of confidence or confidence level you are going to establish. And for number 6, we have computations, and 7, conclusion, and 8, interpretation. So now let us have the example. So we will consider the example on page 69 of our learning resource pack. So we have here, okay, we have here the problem says that there are 2 catalysts being analyzed to determine how they affect the mean yield of a chemical process. Specifically, catalyst 1 currently in use, but catalyst 2 is acceptable. Since catalyst 2 is cheaper, it would be adopted, providing it does not change the process yield. So here a test is run in the pilot plant, and the results in the data as shown in the table. So we have the data shown in the table, and then we are going to determine if there is any difference between the mean yields of using catalyst 1 and catalyst 2. So we are going to determine any difference, and this is a significant difference or not. And then we are going to use the alpha of 0.05, and we are going to assume equal population variances. So the first thing that we are going to determine is what is the parameter of interest. And as we have been reading earlier the problem, we are going to determine the difference in the mean. So the difference in the mean yields. So if we are going to denote that one as our parameter of interest, the difference in the mean yield of catalyst 1 and catalyst 2. So this is now our parameter of interest. So the difference of the two. And it says that if there is any difference, so we can now have our null hypothesis stating that we are going to consider a null hypothesis wherein the mean yield of catalyst 1 using catalyst 1 and catalyst 2 is equal to 0. So their mean yields have no difference. So that is our null hypothesis. So mu1 minus mu2 equals to 0. Alright? And for our alternative hypothesis, we will consider that the mean yield of the catalyst 1 and the mean yield of catalyst 2 have a difference. So meaning, when our null hypothesis states that there is no difference between the two mean yields, we can also denote this one as the mean yield of 1, catalyst 1, is equal to the mean yield of catalyst 2. So therefore, our alternative hypothesis will state that these two are not equal, or they have difference in mean yields. And what will be the test statistic that we are going to use? So we have here in the problem, assume population variance that are equal. And we can observe that we have number of samples, which is 8. So we are going to note that our number of samples is equal to 8. And recalling our previous lesson, this problem involves small samples. So what is the test statistic that we are going to use here? So we will use the t-test. And since we assume that the population variances are equal, then we will use the formula t computed, that is our test statistics, minus x is equal to x bar 1 minus x bar 2, which represents our sample mean for catalyst 1 and sample mean for catalyst 2, minus 0. Why 0? Because we are going to assume that there is no difference between the mean over the pooled variance, sample variance, square root of 1 over n1 plus 1 over n2. So this will be our base formula later on in finding the computed t value. So the next step is we establish a rejection region. So in our t distribution, we're going to establish our rejection region. So we just select what is the confidence level that we are going to consider. So if we are going to consider an alpha, which is equals to 0.05, this would mean that the area here, this area here, this whole area is actually 0.05. And this is our rejection region. So this whole area is 0.05. And if we are going to recall our t table, so we are actually getting t table, the value of the t critical in the t table is found somewhere in this line. So having that in mind, we can say that we will reject the null hypothesis if our p-value is less than 0.05. Okay. So if that is less than 0.05, then the variable will lie somewhere here, and it lies in the rejection region. So if that is greater than, then it will lie somewhere here, and that will mean that we are going to accept the alternative hypothesis. So having that in mind, we will now have our p-value that is less than 0.05 should be rejected, because if that will be less than 0.05, then the area niyan will be lying somewhere here. So we reject the null hypothesis, and then we can now go for or accept the alternative hypothesis. On the other hand, if the p-value is greater than, so the area will lie, the variable will lie somewhere here, and that would mean that we are going to accept the null hypothesis, and that means that there is no difference between the mean yield of the two catalysts. So if we are going to consider the computed T and then compare it with the critical T, which is found in the table, then we will reject the null hypothesis if the computed T is greater than what is seen in the critical table. Why? It's because if this is the value in the critical table and our computed T is greater than, then it will lie somewhere here. So this will be T sub O. If ever T sub O is greater than the T critical. So this is our rejection region. And if ever T sub O or the computed T is less than, then it will lie somewhere here. The value will lie somewhere here, and we can now say that we will accept the null hypothesis. So in this example, we will focus on the usage of the computed T and the critical T found on the T distribution table. So we can now move forward with the computations, conclusion, and interpretation. Okay, so let us now move with the computation. And so we are going to compute for the T values. So we are going to compute for the computed T value. And so we have given the mean of the catalyst 1, which is 92.255, minus the mean of the catalyst 2, and that is 92.733, divided by the pooled variance. So this was also being computed, but we will not show here. You just look at the example on your LRP, and then that is 2.7 square root of n1 is equals to n2 1/8 plus 1/8. So the answer here will be 92.255 minus 92.733 over 2.7. Square root of 1/16 is negative 0.35. So this is our computed T. Okay, so the next thing that we are going to find out is the T at alpha over 2. So since we have a two sample t-test, we are dealing with two sample t-test. Meaning we have two sets of samples. Then we will get the degrees of freedom by adding the 2 minus value of 2. So in this case, our degrees of freedom here will be 8 plus 8 minus 2, and so we have a degrees of freedom of 14. So therefore, we will get the T alpha over 2 degrees of freedom. So we will consider 0.025 and 14. Sorry. So we'll consider T at 0.025 and 14. And the value for that is actually 0.025. So we will consider here. And that's actually the 95% level of confidence. And then cross-section with the degrees of freedom, which is 14. And so we get 2.145. So we have 2.145 as the T in the table. So we will compare this 2.145 and this computed T. So we have a negative value and a positive value. So if we're going to consider our rejection region, we will reject the null hypothesis if the computed T is greater than the critical T. So in this case, the computed T is, our conclusion here is that since computed T, which is equal to negative 0.35, is less than the critical T, which is equal to 2.145, then we fail to reject. We fail to reject the null hypothesis. Meaning, we will not reject the null hypothesis, but we will accept it. So accept null. And what does that mean? So we now move with the interpretation, and if we accept the null hypothesis, then that means that there is no difference. There is no difference between the mean yield of catalyst 1 and the mean yield of catalyst 2. Or there is no difference between the mean yield of catalyst 1 and catalyst 2. So there you go. We now have our 8-step process of hypothesis testing. Thank you.